Hello, I'm Patricia Cramer, and this is Paige Singer, my partner. We're going to be presenting to you a presentation on how we designed and carried out a scientific study of the wildlife crossing structures and other mitigation on State Highway 9 in Colorado. Next. And we'll do next. This study was supported by Colorado DOT, which is CDOT, and Colorado Parks and Wildlife, which is CPW, and a private ranch that is right in the heart of the mitigation area, put in a lot of money and effort to help with it as well. And on the right, you can see our study panel members. Next. I just wanted to dedicate the slideshow and the presentation to my dad, who just passed away. Thanks. Next. The slide presentation is broken into two parts. The first is the study setup, and we give you some hints on how we conducted the study with lots of cameras and our photo analyses, and set that all up ahead of time. And it's presented in a way that you can understand how it might apply to you. And then the post-study analysis is really the post-monitoring analysis. So after the cameras are pulled and all the pictures are analyzed, there's still plenty of work to do. So that's how we'll present the information. Next. So the study setup, we had a lot of people help us with putting 66 cameras out on the landscape and checking cameras. So it was very much a team effort. And as you can see, if you're in the session, there are other people presenting on how it was very collaborative. Next. For the setup, pre-construction monitoring, the objectives of having cameras out on the landscape before the construction starts, there's two very important things that you can learn from those cameras. You can learn what species are present in the landscape that may need to get across the road and who we expect to use the structures. And then how many of them are there out there? So for instance, there weren't very many pronghorn, but it was good to know they were there so that we could set up performance measures to say, hey, the structures need to work in this manner to get this many animals of this species across. So it was important to evaluate what's going on and who's out there before you ever start with bulldozers and pavement. Next. We set up a study to monitor for 5 years post-construction. There's tons of questions that we designed the study to answer, but the main ones that anybody setting up a mitigation study would look at is what structures and features work best for what species. For instance, do bighorn sheep go over overpasses more than they go under underpasses? What can the DOT and their partners do to adaptively manage? For instance, there may be ice through the middle of the structure and the animals are slipping on it, so maybe they can fix it. And then number three, did the mitigation reduce wildlife vehicle collisions, both crashes and carcasses? So there's lots and lots of things to look at to help the DOT and their partners understand how well the work was able to provide connectivity for wildlife and make the road safer for people. Next. So our study in State Highway 9, we had repeats, and that's really important because if you have different structures that are all the same dimensions, then you can look at the effect of what's going on here, if it was structural dimensions or was it its placement on the landscape. So we're very fortunate to have 5 underpasses and 2 overpasses. All the two different sets were pretty much the same dimensions. What's also great, I looked at another study that we did in Colorado, and that 66 feet long length that the animal traverses underneath a 2-lane highway, that's really important because in other studies I've done in Utah as well, that length has to be kept as short as possible and it'll get you more animals and more elk underneath it. So the dimensions of the underpass in particular were nice and big and wide and short to keep animals moving through, particularly things like elk. Next one. So we had repeats of infrastructure that it was not a wildlife crossing as well. We had 12 wildlife guards that were monitored. These are equivalent of double cattle guards. So there were flat ones and round bar ones. And we even had one that had this little grate on it to help people get through. And the next part of the slide, we also had escape ramps. And there were 13 of those that were monitored. And there were different dimensions that we looked at. We had we had escape ramps where there was a fence in the middle of it, like the top one there, without fences. We had them 2-to-1 slopes, which are more steep than the 3-to-1 slopes that are more gradual. And we had one that was below grade. So we were able to look at different repeats, and N equals 6, say, for instance, with the flat bar guards, to see what features were important to the wildlife to get them to do what we wanted, which is to get off of the road and underneath on the structures or on the overpass. Next. And we had multiple cameras. We had a camera at each entrance of each structure and a couple more on the overpass. And we had one at the habitat or wild side looking out to see what animals were present, but that were not coming near the structures. Next. And the ones at the guards, the guards and the escape ramps, we had one in this green box here at the escape ramp in the right of way, where the animals may be trapped in the fenced area, to see who's running along the fence, to see how many do we actually intercept with the ramp and they go up it. And then next slide, we had one on the wild area looking at the ramp to see who's actually jumping off once they're on there. Next slide, we had one camera placed on each wildlife guard at the leading edge. Next slide, to see what animals are doing at that very edge when they're trying to get into the road. Here, the bighorn sheep is turning around, didn't use it. Next slide, and we had one at each fence end to see what the animals were doing when they got around the fence end, if they continued to cross the road, they turned around, or if they came into the fenced area. Next. And so we did photo analyses too. And with the photo analyses, the setup and how that was all done, we're going to talk more about that in the post-monitoring section of the slideshow. Next. We had teams of people looking at carcasses along the road. We had your usual DOT maintenance folks doing it all year. And then we had folks in that Blue Valley Ranch, they're wildlife professionals there, along with Colorado Parks and Wildlife biologists looking at the carcasses in the winter, which is when the majority of the animals were there. Next. So we set up performance measures. We looked at, like, this study will work, or this mitigation will work if wildlife of these different species go through at a particular success rate, if we've got a particular number of successful passages that equate to connectivity, which means, you know, if you have just one pronghorn buck, that might have provided some genetic connectivity, but what about the rest of the population? So it was important to look at the genders, the ages of the species, and see how many were coming through, and then again, set some goals in the beginning. Also, what percentage did you want the wildlife vehicle collision carcasses and crashes to be reduced to say it was successful? Studies typically do at least 75% for that number. Also looking at how well the wildlife guards and other things deterred the animals from coming into the highway, what percentage do you want that to be, and how many successful escapes from the right-of-way where they jumped over the ramps, like what percentage did you want them jumping off? Next. So now we move on to the post-study analysis, and after we gather all that data for 5 years, this is how we analyze the data, and we're able to answer lots of questions and look at it from the performance measure perspective. Next. So the photo analysis is where Paige tells you more about what she did.
Thanks, Patty. So one of my roles in this research was helping to analyze the millions of photos that were generated throughout the life of this project. And through this analysis, our ultimate goal was to determine the number of individuals and, if possible, their gender, the direction of origin, and each individual's response to a given mitigation feature. To do this, photo data were systematically processed to identify movement events every time a camera was triggered, and events were defined as 15-minute time periods based on the previous methodology developed by Patty. In most cases, concurrent photo series were analyzed from multiple cameras at a given mitigation feature to determine each individual's response. For instance, photos from the 2 cameras at each underpass were analyzed together to determine if an animal successfully made it all the way through the structure, like this bear or these mule deer bucks. The 2 overpass structures each had 4 cameras that were used together, a graphic of which you can see here in the upper right. And at these structures, each individual's response was documented as a successful passage, rappel, or parallel movement. Successful passages were movements all the way through or over the structure. Rappels were recorded when an animal initially began moving near or into the structure, only to turn back the same way it came. And parallel movements were recorded when an animal moved near the structure but didn't show any behavior indicating they were trying to use the structure. Direction of origin was determined based on the orientation of each camera, which can be hard to keep track of when you're dealing with multiple cameras. So we created a cheat sheet for each camera grouping to help us keep all of this straight. And you can see an example of that here on the lower right. Similarly, photos from the 2 cameras set up at the escape ramps were analyzed to determine whether an animal ignored the ramp, repelled from the ramp, used the ramp to escape from the right-of-way side, or breached the ramp by jumping or climbing up the ramp to the right-of-way side. 1 camera was used at each monitored wildlife guard, small culvert, and fence end. At wildlife guards, movements were categorized as a breach movement if an animal was able to move from one side of the guard to the other, a rappel, or a parallel movement. At small culverts, successful passages were tallied when an animal entered and did not reemerge within 15 minutes, or when an animal emerged without previously having entered. And finally, at fence end, camera data were analyzed to determine if animals moved into the fence right away, from the fence right away, or if movements occurred beyond the fence end. Gender for mule deer was recorded from June through December, when antlers are most apparent and before they are shed. Young of the year were classified as fawns and excluded from gender totals. And gender of non-antler species was only recorded when a mom obviously had young with her, such as this black bear with her cub, or this mountain lion with her kid. Recording the gender and age of animals using the structures is important because it gives us a better understanding if connectivity is being maintained or improved for all members of the species population, not just individuals. So all of this information were recorded in an SQL database that was created for this research. You can see what a spreadsheet from that database looks like here, and you can see the different columns for the various data elements that we recorded. So all of this photo analysis allowed for us to determine various indices at each crossing structure. So this is the total number of approaches for a species at each structure, total successful passages, as well as success rates. The total number of individual successful passages divided by the total number of individual approaches by a species. Rappel rates and parallel movement rate were calculated similarly. Other mitigation features had additional indices that were also calculated. For more common species, such as mule deer, success and rappel rates allow for comparisons across crossing structures in this study and with other study areas. But numbers for more rare species like bighorn sheep, which you can see here, we only recorded 37 approaches, limit our ability to extrapolate to other locations because of their small sample size.
All right, thank you, Paige. And from that information that Paige put together, we were able to show success rates as a function of all the animals that were there, the total movements or total approaches. And then on the right, you could start to see what structures the animals use more often. For instance, the dotted lines show the use of the overpasses. Next slide. Habitat camera showed us things like elk and badger that were behind your cameras at the structures, but were not necessarily coming there. So it's important to see who's there and who's actually using your structure and making some judgment as to what's going on and what you can do to improve their use. Next one. 5 years of monitoring are really important. This slide here shows you how in year 4, elk use started taking off at a particular structure in the wintertime, and we would never seen that, and it continues to increase. So you might make incorrect assumptions if you only looked at 2 or 3 years of data while the animals were still getting used to the landscape. Next. We looked at variables on the landscape that might affect the animal's use of the structures. For instance, things around the structures themselves, such as the slope or the drainage, and then distance to human disturbance. And next slide. The analysis found that there was almost no effect of the landscape or structural variables as to why things were used more in some places. It really turned out, if you look at it, the number of successful passages really was looking at how important that structure's location was. So location, based on historic movement patterns. We also think there might be some other factors that we weren't able to measure, like forage quality or depth of the snow. Next. If you look at this great map that Paige made, on the left is where all the carcasses were per mile marker along the study. And you can see a great decrease from left to right, how few there were after the mitigation was put in. Next. But what's really important as well is this red circle shows you these are the areas here where the most animals were getting killed. So it turns out the structures that were right there were the places where we had the highest mule deer use of structures. So there was a direct correlation with location and numbers of carcasses and number of animals using structures, in particular mule deer. Next. And so we found that we reduced collisions by at least 90%, depending on crash or carcass data. It worked really well. Next. And we did a Bakke analysis, which we don't really have time to go into right now, but it's before, after control and impact to look at crash rates in the area that was mitigated and controls nearby. And through complex statistics or t-tests, you can see how well it worked. Next. And so what we found was, for sure, we believe that the mitigation was responsible for the great decrease in crashes. Next. And the performance measures, there was great success rate by many species, but there was low functional connectivity for some species where you only had things like a couple of males or just a couple of animals. So it was very good to get the Paige's information on the photo analysis to see who and the gender and the age was using the structure and how they're working for the total population and that connectivity, not just a few individuals. Next. And our recommendations were that the designs of the crossing structures work well for mule deer. You have to adaptively manage. Some structures don't work for all animals. Bighorn sheep like overpasses, and a couple of other designs on that other infrastructure. Next. And that's it. Thank you very much.